You can see that if you keep decreasing the area, you make a converging nozzle. After some time, you will see that there is no increase in the throat anymore. Right? So if you have this kind of shape, the smallest area is the area that called the throat. Okay? This is the area where the sonic flow begins. Okay? Only here. The sonic area in the nozzle only occurs in here. Before it is subsonic, after it is supersonic. And there is no way you can achieve a supersonic if your throat area is not in a sonic zone. No way. You can only reach supersonic over there if here you get sonic flow. Similarly, there will be no normal shock occur if here you got no sonic. Because if there is no sonic, there will be no supersonic. If there is no supersonic, there is no normal shock wave. Okay, here. Okay. Anyway, if you look at this, you will see that this one is same with your Venturi nozzle for the incompressible fluid flow. Venturi nozzle is usually used to measure the velocity, right? You measure the pressure and the area because the m dot is equal to rho AB, m rho is constant, right? So you got A1, P1 is equal to A2, P2. And then on the Venturi, you will get your pressure, right? And then P1 over gamma plus P1 square over 2G plus Z1 is equal to P2 over gamma plus P2 square over 2G. No G, right? Because it's gamma. P Z plus Z2, right? Usually Z and Z is cancelled, so you can calculate P like in here, you get your velocity. That is Venturimeter. But this one, even though the shape is the same, but the concept is totally different because you are dealing with incompressible. So your rho cannot be cancelled. Okay, rho will be there. Okay, so because it is not compressible, it is not incompressible flow, we need to coming back to our conservation of energy, right? If there is no heat losses, because we are talking about isentropic. Isentropic means adiabatic, reversible. Adiabatic means constant temperature. Adiabatic, no heat transfer, which means your Q is 0. There is no work coming in. In a nozzle, there is no work, right? Unless you are dealing with the turbine, then there is work input or work output. But here we are talking about nozzle, so there is W is 0, and the location of nozzle usually is not so far. Even though you make it sangat like that or like that, still the difference in elevation is marginal, right? So your delta P is equal to 0. So you got H1 plus P1 square over 2 is equal to H2 plus P2 square over 2, which means it is constant. When you take the differentiation of it, you get this PdV. You know how to get it? I don't have to show you. Take dH, dV square over 2. dV square square over d something, dv square. So if you have a dv square, I can make it like a dv square over dv you take this one dH over dL, this one dV over dL, dL times 0 is equal to 0, so you got this one. Okay, and then also from the isentropic condition that TdS is equal to dH minus PdP, this one is the workflow, remember that? Hopefully in your thermodynamics, right? Ask Shaifuddin again how to derive it, right? When you substitute, you'll get dP over rho is equal to P dV equal to 0, and then from this one is from the mass flow rate. Okay, mass flow rate, you take integration by part or partial integration, you get below below over rho, dA over A, dV over V is equal to 0, right? Because you take derivation of it, dm over something is equal to 0. So you plug in there. If you do that, you get this. Okay. So from here, boys and girls, if you rearrange, it becomes this. Okay. How to rearrange it? You try it on your own. If you do not want, just trust this. Okay. So you got this one. So this correlation, okay. Now this is the important part. Okay, if you want to pay attention, you can pay attention. If you do not want to pay attention, it's up to you. Don't cry during the test. Don't ask me during the test also. That is the time that I want to laugh. Right? So you can see dA over A with the dV over V. The changes of area and the changes of velocity. Okay, now you see, when Mach number is below 1, this one become positive, right? This one positive, this become negative. What does it mean? When the area becomes smaller, mean dA is negative, right? Negative, so you get increase in velocity. Clear? Can I repeat? Yes. When Mach number is below 1, or when you are in the subsonic zone, this one become positive. Here you get negative. Which means if your area is decreasing, which means A2 is smaller than A1 divided by A1, you get negative, right? Negative, but dV over V is also negative. You move it there, negative with negative, you get positive. Positive or negative? Positive. Which means you get your dV is bigger, right? Or dV is positive. See, dV is V2 minus V1. dA is A2 minus A1. When you have subsonic, right, your dA will be dAA is equal to minus dV V, because the rest is positive, right? If you want V2 to be higher than V1, so your dV will be positive. So if you want this to be positive, this one have to be negative, which means your A2 will be smaller than A1. That one is for subsonic. If you want to decrease the velocity means V2 is smaller than V1, dV become negative. Negative, gone. So this one become positive, right? Which means you increase the area when you want to reduce the velocity. Okay? That one is true when you have Mach number below 1. What happens if your Mach number is above 1? 0. When your Mach number is 1, doesn't matter how you change your profile, the maximum velocity will be Mach number 1. Right? 0. area does not play important role in the sonic zone. Okay, when you have a critical condition. Yeah. Now, when Mach number is more than 1, you see that this one will become negative, right? Negative times negative, positive. So if you want to increase the velocity, you need to increase the area. If you want to decrease the velocity, you need to decrease the area. Okay? That is the reason why when you see a supersonic jet, they have this and that.